Hi everyone! The purpose of this video is to learn how to balance redox reactions in acidic solutions. You only need to know how to balance redox reactions in acidic solutions. It's also possible to do it in basic solutions, but that's not necessary for the IB. All right, so we have this example of SO3 2 minus plus MnO4 minus yields SO4 2 minus plus Mn2 plus. Notice we have a net ionic equation. In the true reaction, there are spectator ions attached to all of these ions here, but in order to balance, we don't actually need to deal with the spectator ions, just the things being oxidized and reduced. All right, so let's dive in. The first thing I'm going to do is assign oxidation states. In order to assign oxidation states, I take each species, and I start with the most electronegative atom. I put the oxidation state I would expect based on the periodic table, which is why I wrote -2 next to oxygen. Oxygen's more electronegative than sulfur. It's closer to fluorine in the periodic table. Oxygen has 6 valence electrons, tends to gain 2 to get to a full shell, so -2. 3 oxygens in total would have a charge of -6. All right, in order to get to my total charge of 2 minus, I need sulfur to be +4. A little weird for sulfur to be +4, but we do the other atoms based on the more electronegative atom. Great. Oxygen in MnO4 minus, again, -2, -8. Manganese, therefore, needs to be +7. SO4 2 minus, oxygen is -2, -8, +6. And that's what gets me to the 2 minus for sulfate there. Manganese, they already tell us, is an ion with 2 plus. That means that its oxidation state is +2. All right, the next thing I'm going to do is I'm going to write my half reactions, my reduction and my oxidation, and I'll separate those out. Reduction, I'm going to move this up a little bit. Reduction and oxidation. All right, so what's happening? +4 to +6. I'm becoming more positive. If I'm becoming more positive, that means I lost electrons. And remember, oil rig oxidation is lose. So that means I'm oxidized. Great. Manganese, 7 plus, or +7 to Mn2 plus. I'm becoming more negative or less positive. That means I gained negative things. I gained electrons. That means I'm reduced. All right, so I can write this out. MnO4 minus yields Mn2 plus, and really I should have left room for my electrons here. So MnO4 minus yields Mn2 plus. Remember, I go from +7 to +2. That means I needed to gain 5 electrons. So +7 plus 5 electrons gets me to a charge, or an oxidation state, I should say, of +2. I'm going to erase these extra numbers so that they don't look too confusing. Oxidation, SO3 2 minus yields SO4 2 minus. Remember, I went from +4 to +6. That means I lost 2 electrons for the charge to change by 2. And I show that on the other side of the equation. So here are my half reactions. If you're not sure how I got these, pause the video, go back, watch, ask questions in the homework document. Make sure you know how we got these half reactions before we move on. All right, so our next step in terms of balancing is, so I'm going to be writing my steps over here. First, I had to find oxidation states. Now I've written half reactions. Now I balance atoms that are not oxygen or hydrogen. 1 manganese, I'm good. 1 sulfur, I'm good. All right, now here's where I balance the H's, and the O's. And I do that with H2O and protons. Now here's where the acidic solution piece comes into play. If I were in a basic solution, I would use H2O and OH minus, but I'm an acidic solution, I have excess protons, so I'm going to balance my hydrogen and oxygen with H2O and H+. All right, so let's see that. I'm going to erase these labels so we have some space to work. Looking at my first half reaction, I see I have 4 oxygens on the left. That means I'm going to need more oxygens on the right. So I'm going to add 4 H2Os so that my oxygens are balanced in my reactants and products in this half reaction. Great. Now I've added some hydrogen. That means I need to balance that as well. So 8 H pluses or 8 protons, 8 hydrogen ions on the left. So now I've balanced H and O in my first half reaction. I'm going to look at my second half reaction. Similarly, I'm going to start with oxygen. I see it's not balanced, so I'm going to balance that with water. I need one more water atom, or one more oxygen atom, excuse me, in order to be balanced. And now I've added some protons. Now I've added some H+. So I've just added 2, so I need to do plus 2H+. All right, so I now see that my hydrogens and my oxygens are balanced on the left and on the right. All right, this next step often is not necessary. We'll see if it's necessary in this case. But the next thing I need to do is I need to check the charges in my half reactions, in the reactants and products. And I need to make sure that they're equal to each other. What do I mean by that? Well, I have 8 H+, so the charge there is 8+, and minus 5 minus, so in total I have 6 negative things. So my total charge on the left here is +2, 8 minus 6. Similarly, on the right, the charge that I have is +2. I'm balanced in terms of charges. I'm going to do that same thing in the second half reaction. I have 2 minus on one side, so my total charge on the left, -2. And then on the right, I have 2 minus, 2 negative, so that's -4, and then 2 protons, so +2, so +2 on the right. And so I am balanced in terms of charges. I'm balanced in terms of the total charge on the left and right in each half reaction. All right, now is when I consider the half reactions in comparison with each other. So instead of balancing each half reaction independently, now I balance everything together. I look at everything I have on the left and everything I have on the right. These are going to be all of my reactants and all of my products in my final equation. What I need to balance now is the electrons that I've added. So I need to balance electrons that I've added for redox. I see I have 5 electrons on the left, 2 electrons on the right. So I need to make it so that this number of electrons in my oxidation and this number of electrons in my redox are the same. How would I do that? Well, I need to multiply this by 2 and this by 5. This is getting a little busy, so let's write this again. So I have, I'm going to choose another color just so it's clear. So my reduction reaction, I now have 2 times 8 is 16H plus 2 MnO4 plus 10 electrons yields 2 Mn2 plus 8 H2Os. All right, my oxidation, I now have, I'm just distributing this 5 H2Os plus 5SO3, 2 minus, yields 5SO4, 2 minus, plus 10 electrons, plus 10 H plus. All right, now my final step here is combine my half reactions and simplify. So I'm going to take my reduction and oxidation reactions, I'm going to copy them, and let's combine them. Yep, that looks a little silly. Okay. All right, so everything on the left and everything on the right is going to go together. These will be all of my reactants. These will be all of my products. All right, so I have 16H plus 2MnO4. I believe that was MnO4 minus. I think I've lost a negative sign. Okay, MnO4 minus plus 10 electrons plus 5H2O plus 5SO3, 2 minus. So that's everything here, yields 2Mn2 plus 8H2O plus 5SO4, 2 minus plus 10 electrons plus 10 protons. Oh my goodness. Trying to make everything fit. This looks a little silly. My handwriting got smaller and smaller. Plus 10 protons. Okay, great. So now I'm almost done. I just need to cancel. I see 10 electrons on the left, 10 electrons on the right. Those cancel out. I see 5 waters here and 8 waters here. So 5 waters cancel with 5 of these water molecules. I have 3 left over, so this now becomes 3H2O. Similarly, I have 16 protons here, 10 protons here. So 10 of these protons start in the reactants, end up in the products. So net, the difference is 6H plus. So my final ending reaction is 6H plus 2MnO4 minus plus 5SO3, 2 minus, yields 2Mn2 plus 3H2O plus 5SO4, 2 minus. And there we are, nice and balanced. And you can check each of the atoms, 6 hydrogens, 2 magnesiums, 2 magnesiums. I have 2 times 4. 2 times 4 is 8 oxygens here. 5 times 3 is 15 oxygens here. And so in total, I have 23 oxygens. 23 oxygens. Here I have 3 plus, 3 oxygens plus 20 oxygens. So again, 23 oxygens. So my oxygens are good. 5 sulfurs, 5 sulfurs. I am balanced. All right, thanks for watching. Let me know what questions you have.